Today we're going to start Unit 2 in Math 1, and this is going to dive a little bit deeper into linear functions. Today we're going to talk about evaluating functions and the domain of a function. So number 1 says, given f of x equals 5x plus 9, what is f of 8? So let's talk about a little bit of the terminology here. This right here is read f of x. It is the same thing as a y. It's just kind of like a dressed up y. So my job is to find the function at 8. Well, if you'll notice, if you write the f of x, the 8 has just replaced the x. So basically we're saying if x equals 8, what's y? If x equals 8, where is this function at y? So all I have to do is take this 8 and plug it in for all my x's in my function. So f of 8 just means take an 8 and put it in for your x's. So that would be 5 times 8 plus 9, which would be 40 plus 9, which is 49. So f of 8 equals 49. And that's completely sufficient for this problem. But what this means is that if x is 8, y is 49. And another way to think of that is this function goes through that point, 8, 49. So number 2, given f of x equals 10 minus 2x, what is f of negative 1? So I'm going to take this negative 1 and I'm going to plug it in for my x. And I'm going to be real careful with my signs. So 10 minus 2 times negative 1. Bring down my 10 because I have to multiply first, order of operations. That is a negative 2 times a negative 1, and that's a positive 2. And 10 plus 2 is 12. So f of negative 1 equals 12. And again, another way to think of that is that you just created the point negative 1, 12. The charges for Smarty-Pants Tutoring Company are represented by the function f of x equals 50 plus 10x, where x represents how many hours they tutor. How much do they charge for 10 hours of tutoring? Well, if you remember from Unit 1, this function means that they charge $50 up front and $10 per hour. I'm going for 10 hours. We did this in Unit 1. All you're going to do is plug a 10 in. But what you're really doing is you're finding f of 10. So I take my 50 plus my 10 and I plug my 10 hours in for that x. Again, order of operations tells me I have to multiply first, and then I add. So f of 10 equals 150. So 10 hours is going to cost me $150. The function 10n minus 2 could be used to find the total number of hours Callie has studied after n weeks of school. So again, let's focus on what the variable represents. So n is the number of weeks in school. How many hours did Callie study between week 10 and week 13? Well, between just wants the part in between 10 and 13. So what we're going to do is we're going to find f of 10 and we're going to find f of 13. And when we get those two answers, we're going to subtract them because that's the between part. So f of 10, so 10 times 10 minus 2, which is 100 minus 2, which is 98. F of 13, plug in my 13 in for my n because it's week 13. That's 130 minus 2, which will be 128. So now to find the difference between these two, I'm just going to subtract them. And I want a positive answer because we're talking about hours. So I'm always going to do the biggest one minus the smallest one. So 128 minus 98, which gives me 30. And these are hours. So she studied 30 hours in between week 10 and week 13. The function f of x equals 5x minus 4 could be used to find the total number of minutes Jessica has used after x days. How many minutes did Jessica use between day 12 and day 16? Again, there's that word again. So I'm going to find f of 12, and I'm going to find f of 16, and then I'm going to do what? I'm going to subtract them. So f of 12, using this function, and I'm going to plug a 12 in for my x. So 5 times 12 minus 4. 5 times 12 is 60. Minus 4 is 56. And then I'm going to find f of 16. Use my equation, my function. So 5 times 16 minus 4. 5 times 16 is 80. And 80 minus 4 is 76. So she used 56 minutes on day 12 and 76 minutes on day 16. And I want to know how many minutes she used in between. So I'm going to subtract. We're talking minutes, so I want positive. So I'm going to do the bigger number minus the smaller number. And that gives me 20 minutes. Suppose that the function f of x equals 0.1x plus 7 represents the cost to download x songs a month from an internet music club. Well, let's go back and look at this. What does this mean in terms of buying? It means they're going to charge me $7 flat just to join, and they're charging me what per song? And that's 10 cents. It's not a penny. It's 10 cents per song. Arthur now has 10 bucks. How many more dollars does Arthur need to buy 60 songs? This is where it's really important to read, not just find numbers and start plugging them into things. If he's got 10 bucks, he does not have enough to buy 60 songs. So what's the first thing I need to find? I need to find how much money it cost to buy 60 songs. X represents songs. Well, this is 60 songs, so I'm going to plug my 60 in for X. So I'm finding f of 60. How much is it going to cost to buy 60 songs? 0.1 times 60 is 6, plus the 7, so 13. So what does this number represent? Well, it costs $13 to buy 60 songs. And 13, if it's supposed to multiple choice, 13 would definitely be one of your choices. But it wants to know how much more money does he need? Well, he already has $10. So how much more money does he need to get his 60 songs? He needs $3 more. So be really, really careful on this one, not to just stop as soon as you think you've solved it, but go back and make sure you read the question and make sure you answer it. The function c of m equals 3m plus 10 represents the cost to rent M movies a month from an internet video club. Okay, again, M stands for the number of movies. Kimberly now has 8 bucks. How much more money will she need in order to rent 8 movies this month? Well, if M stands for movies, I need to figure out how much it's going to cost for her to rent these 8 movies. So I'm finding C of 8. So 3 times 8 plus 10. 3 times 8 is 24 plus 10. So it will cost $34 for her to rent her 8 movies. Let's make sure we answer the question. Kimberly now has $8. How much more money will she need in order to rent these 8 movies? Well, she needs $34 and she has $8. So 34 minus 8 means she needs $26 more to have enough money to rent her 8 movies. So $26 is your answer. The function f of x equals 0.05x plus 30 represents the monthly phone bill in dollars for x minutes of calls. Alexis now has $25. How much more dollars does Alexis need for 500 minutes of phone calls? So if this represents her phone bill, we know that they're going to charge her $30 up front, 5 cents a minute. X represents the number of minutes. She has $25. We don't need that information right now. We need to know that she wants to make 500 minutes of phone calls. Well, if X represents minutes, I need to take my 500 and plug it into my equation. So I'm finding f of 500. .05 times 500 is 25 plus the 30, 55. So what does this number represent? Well, this is the cost to use 500 minutes. She already has $25. How much more money does she need? She needs 55 total. She already has $25. She needs 30 more dollars in order to be able to use her 500 minutes. Okay, going to change gears a little bit. And looking at a problem like this can look pretty overwhelming, but it's really not that bad. So I want you to shift your brain from math to money. So think quarters and dimes and nickels and change in your hand. Bart noticed that there are multiple combinations of quarters and dimes that add up to $1.25. X is going to represent the number of dimes, and Y represents the number of quarters. What is the domain? This is a vocabulary word that you should have seen before. Domain means X. Domain is X and range is Y. We're focusing on the domain. So when we're talking about the domain, are we talking about dimes or quarters? Well, if the domain is X, X represents dimes. So this is what I'm concerned with. I'm trying to reach $1.25. So all of these numbers down here is a list of how many dimes I can have. Doesn't have anything to do with quarters because we're only talking about the domain. So can I reach $1.25 if I have 0 dimes, which means I have the rest quarters because I only have dimes and quarters. If I have all dimes and all quarters, and I'm trying to reach $1.25, can I get there if I have 0 dimes and all quarters? Can I reach $1.25 if I have all quarters? And the answer is yes, it would take 5 quarters. So I like 0. Well, since I like 0, do you see how B does not have a 0, doesn't have 0 dimes as an option? So we get to take him out. C has a 0, but D does not, so we get to take D out. Now, between A and C, they both have a 5. So I don't need to test 5. What I need to do is test the 1. Okay, well, think about what this number represents. This represents the number of dimes. So if I have 1 dime, can I get to $1.25 if the rest is quarters? Well, if you have 1 dime, how much money is that? That's 10 cents. So how much does that leave me with? If I have 10 cents and I'm reaching $1.25 and 10 cents of it is a dime, I'm now down to $1.15. So now if I can have 1 dime, I need to be able to have the rest quarters. Can I hit $1.15 with the rest of the money being quarters? And the answer is no. If I have 4 quarters, that'll hit $1. But if I add another quarter, that'll take me all the way to $1.25. I don't want to hit $1.25. I already have 10 cents. So I need to hit $1.15. And I cannot do that with all quarters. So I cannot have 1 dime. So he's out. So the answer is C. And I know this can be a little confusing until it clicks, but let's think about the 5. If I have 5 dimes, how much money is that? Well, that's 50 cents. Okay, and that's all I have for dimes. Well, how much of this $1.25 is left if 50 cents of it is dimes? So if you take 50 cents away from $1.25, think money, what do you have? You have 75 cents. Can I hit 75 cents if the rest of it is quarters? And the answer is yes. So I can have 5 dimes because that gives me 50 cents in dimes. And then I can have 3 quarters, and that gives me my 75 cents. And the two of them together give me the $1.25. All right, just for kicks, let's try the 10. If I have 10 dimes, how much money do I have? I have $1. Okay, if $1 of this is all dimes, how much is left? 25 cents. Can I hit 25 cents with only quarters? And the answer is yes, and that's why I can be 10 also. All right, let's try another one. Daniel noticed that there are multiple combinations of nickels and dimes that add up to 65 cents. Okay, so now we're nickels and dimes. X represents nickels, Y represents dimes. I want the domain, so I'm talking about the X's. The X's are nickels. So I have nickels, which are 5 cents, and I have dimes, which are 10 cents. I'm trying to hit 65 cents total. Okay, X represents nickels. So all of these answers right here have a list of the number of nickels I could have. So let's see, can I have 0 nickels? If I have 0 nickels, then I have $0, 0 change. So that means the rest of it has to be dimes. So can I hit 65 cents if it's just dimes? And the answer is no. I can hit 60 and I can hit 70, but I cannot land on 65. And again, this is with 0 nickels and all dimes. And the answer is no. So I can't have an answer that has a 0 in it. Okay? So now let's look at B. So B has a 1 and so does D. So 1's got to work, but I'm just going to talk you through it. So if I have 1 nickel, then that's 5 cents. If I have 5 cents, how much of the 65 cents is left? And the answer is 60 cents. Can I hit 60 cents if I have the rest dimes? And the answer is yes. So I can have 1. All right, let's try the 2. If I have 2 nickels, how much money is that? That's 10 cents. So 10 cents of the 65 cents is nickels. How much money is left? That's 55 cents. Can I hit 55 cents with dimes? And the answer is no. I can hit 50 cents. I can have 60 cents, but I cannot hit 55. So I cannot have 2 nickels. It doesn't work. Okay, and D, just for further clarification, let's try the 3 and I'll show you that it works. So if I have 3 nickels, how much money is that? Well, that's 15 cents. So 15 cents of my 65 cents is nickels. How much money is left? Well, if you take 15 cents from 65 cents, you have 50 cents left over. Can I hit 50 cents out of all dimes? And the answer is yes. That's why 3 works. Same thing for the rest of them. All right, Brenda is planning a birthday party for her 10-year-old daughter. The function which models the catering cost, C, so C represents catering, is C of P equals 8P plus 25. The first question that should pop in your mind is, what does P represent? And it should tell you right after that. P is the number of people. So it makes sense that our catering cost depends on the number of people. So this whole equation represents my catering cost, and P represents the number of people. The room where the party can be held, the room where the party will be held, can only hold a maximum of 30 people. What is the practical domain for this function? Practical domain. Okay, domain, we just learned were the x's. Well, I don't have x's and y's in this problem. So you have to think about what's in place of where the x normally is. And the answer is the p. Okay, well, what does p represent? Does p represent the cost, or does it represent the number of people? Well, p represents the number of people. So what is a practical domain for the number of people coming to this party? Well, if you say it's all real numbers, you're talking about -100, -6, 0, 4, 5,000. I mean, both numbers in both directions, all positive and all negative. That doesn't make sense. I can't have negative people to the party. And I also can't have 5,000 people to this party because it said we can only have a maximum of 30 people. So this doesn't make sense. Okay, well, B fixes a little piece of this. It says all positive numbers. So, okay, we're taking out all of our negative numbers. Well, that makes sense because you can't have a negative number of people. But does it fix the end up here? Can I still have 5,000, 5 million, a trillion people to this party? No, it can only fit a maximum of 30 people. So all positive integers is out. Okay, now C tries to address a little bit of this. It says all real numbers less than or equal to 30. Okay, so now it's taking into account that we can have a maximum of 30 people. But what is the difference between C and D? C says all real numbers less than or equal to 30. So if I think about a number line, we're talking about that, and it goes forever. So now we're talking back down here where all the negative numbers are. I can't have negative people to a party. So D is sort of the best of both worlds. D says, okay, I got you. You got to be positive, but you also have to be less than or equal to 30. So positive means bigger than 0, but I still have to be less than or equal to 30 because the place can't hold any more than 30 people. So practical means I can't have negative people to a party, so I don't want this part. And I also can't have any more than 30 people because the room can't hold that many people. So D is our winner. So practical domain just means what makes sense. Domain, you've got to go figure out who the x's are. Who the x's are, and that here is people. Number 12, last one. It says attendance for the school play is a function of the ticket price and is shown below. Attendance for the school play is a function of the ticket price and is shown below. What is the practical domain? Okay, again, domain is x. Well, on a graph, x's go this way. These are my y's. So x's. And this is attendance and a ticket price. So would these numbers down here be attendance or ticket price? If you're not sure, look at these numbers here. Would these numbers be attendance or ticket price? This has got to be attendance because you're not going to have a ticket that's $500. So this is your price. This is your attendance. No, I'm sorry. This is not your price. I'm sorry. I said that backwards. This is your attendance. This is the number of people. This is your price. So look, as the price increases, what happens to my attendance? It goes down because not many people are going to pay $40 for the school play. Very few people are going to pay $50 for a school play. What happens when you get past $50? This line goes negative. Well, that doesn't make sense because you can't have negative people at a play. So what this means is we need to cap it at 50. So, and I can't have a negative ticket price. So I need something that says I've got to be positive because I can't have a negative ticket price. And I don't need to go higher than 50 because if I do go higher than 50, I'm going to have nobody at the play. So which one of these says greater than 0, which means it has to be positive, but it also has to be less than or equal to 50. All real numbers means every single number. This is all real numbers greater than 0. That does take the negatives out, but it doesn't cap it at 50. This is all positive integers less than or equal to 50. I kind of like that one. This one says all positive integers between 0 and 500. D is trying to throw you off and get you looking this way. But we know that that was the attendance, and we're talking about the domain, the ticket price. Normally, I don't go over the on your owns in the notes, but just to give you 2 more examples, let's try these 2. It just does a nice little overview of what we've gone over so far. So, suppose that the function f of x equals 2x plus 12 represents the cost to rent X movies a month from an internet movie club. So this movie club charges $12 flat and $2 a movie. Zach now has $10. How many more dollars, and this is what I would box in, does Zach need to rent 7 movies? So he wants to rent 7 movies. So do I plug in the 7 or the 10? I'll plug in the 7 because X represents movies. So f of 7 equals, so that's 14 plus 12, so it's 26. So it will cost him $26 to rent 7 movies. He already has $10. How many more dollars does he need? So he needs $26. He already has the 10. He needs $16 more to rent his movies. Kristen gets a $20 bill each time she babysits. And $5 bill each time she mows the lawn. She wants to know what combination of these bills could add up to $85. Okay, so we're not coins anymore, we're dollar bills. So she wants $85. She's going to let X equal her $5 bills. Those are the ones we're interested in, but the rest has to be made up of 20. So I've got $5 bills and $20 bills. We are interested in these, and I want to earn $85. Okay, A starts with a 1. Let's go test the 0 first since it's the smallest. So can I have 0 $5 bills, which means I have all 20s and I hit $85? And the answer is no, I can't hit $85 with all 20s. So both these answers that have a 0 are out. Okay. Now both of these have a 1, but just for further explanation, I'm going to show why it works. If I have one $5 bill, how much money would be left? And that's 80. And can I hit $80 from all 20s? And the answer is yes. So that's why I get to have the 1. Okay, so the next one we're going to test is the 3. So if I have 3 $5 bills, that's 15 bucks. How much money is left if I take 15 away from 85? And the answer is 70. Can you hit 70 bucks with 20s? And the answer is no. So 3 does not work. So he's out, and he's my winner. Again, for further explanation, I'm just going to show you why the 5 works. So if I have 5 $5 bills, I have $25. If I take that away from $85, I have 60 bucks left. And can you hit 60 bucks out of all 20s? And the answer is yes. So I hope this helps to clarify. Just remember that domain is talking about the x's. And you have to figure out what the x's represent for domain.